Scientists are developing new formulas for concrete and are looking for ways to make it stronger, more environmentally friendly, and capable of doing things we never thought possible. Back where it all started, at the heart of the Roman Empire, concrete has taken a new and exciting turn. Just a few miles from the Pantheon, the Jubilee Church, designed by architect Richard Meyer, uses a new form of concrete. The church was commissioned by the Archdiocese of Rome to commemorate 2,000 years of Christianity. For that, the building would need a material that was both ancient and modern, a material that would speak to the church's past and make a bold statement for the future. They would also need a material that would last the test of time. Concrete fits the bill.
This church is remarkable for several reasons. It has these three sail-like forms, loosely representing the Holy Trinity, but made in effect of giant concrete blocks.
The shells of the church, which stretch out and up in the same way as the Sydney Opera House, are made of 346 white, reinforced, precast concrete blocks.
Concrete, for all of its advantages, does tend to pick up discolorations from the atmosphere and so on. Meyer, though, wanting to keep his building white, managed to work with local firms in order to achieve this concrete mix that included these photocatalytic particles that will absorb and neutralize the acids in the air. And in effect, what you'll have is a pollution-eating building.
Italcementi came up with a revolutionary new formula for the concrete that will keep it as pristine in 50 years as it was on opening day. All concrete structures tend to stain and degrade from pollution. Over time, this has given concrete a bad reputation. But the unique formula for the Jubilee Church contains a secret weapon: photocatalytic particles.
Now, in effect, what these do, when activated by the light of the sun, they mix with the acids in the air and neutralize those acids, neutralize the discoloration that would come typically from atmospheric pollutants. So, in a way, you kind of have a self-cleaning building.
This test demonstrates the photocatalytic particles at work. The concrete neutralizes pollutants, allowing it to maintain its brightness and not degrade over time. It is a revolutionary new development that has the potential to transform the way we look at concrete forever. Concrete isn't just working harder, it's working smarter. New developments in concrete technology now allow for what used to be unthinkable: helping the environment by using an unusual aggregate: glass.
The innovation here has been in making sure that the glass doesn't get corroded by the lime in the cement mixture. One of the biggest issues with concrete is that the Portland cement tends to be quite corrosive, and this has been a big problem with things like recycled glass. It tends to corrode the glass falls out. This composition of cement was actually developed by Columbia University. It is a much less corrosive, more benign cement, allowing you to put the glass chips in. So you can actually now have concrete with glass chips that actually has a good surface effect.
We are generating millions of tons of garbage, solid waste, and in New York City, approximately 6% of all solid waste is glass. It's bottles like this, yeah? And these bottles generally find their way into landfills. And that costs taxpayers hundreds of millions of dollars just to get rid of these bottles.
Concrete's versatility allows it to bind with other materials, in this case, glass. The first step is to separate the bottles by color.
And then you crush them in a crusher. Now, crushed glass is not something like this. This is what we call broken glass, and that is something you want to handle very carefully. It has sharp edges, and that was also one of the problems we were facing, because skeptics asked, well, if you use glass in concrete, won't people cut their hands by handling the blocks or whatever? Answer is no, because when you crush the bottles in a high-impact crusher, it comes out in pieces like that, and it's just like sand. It does not have sharp edges.
Eventually, the broken glass is crushed into a fine powder.
So this is just like powder, like baby powder, the same kind of size, particle sizes. So if you put this finely ground glass powder into concrete, you can replace part of the cement by this glass.
These are actually 100% recycled glass pieces added into the concrete.
Initially, scientists thought that recycled glass would make for a bad aggregate. But Professor Meyer and his team have found a way.
Okay, so once you make concrete out of these glass particles and color coordinate that very well, then you can get something like this, and this is now already being commercially produced. That's the way how regular concrete would look. And this is here our glass concrete, polished to a high precision, high grade of polishing. And that is known as terrazzo concrete.
Using recycled glass as an aggregate is just one of the many ways that concrete continues to reinvent itself. It also may pave the future for a more environmentally friendly concrete. There are also other developments reshaping concrete for the future. For the last 100 years, architects and builders have sought a way to allow light into concrete buildings, homes, and offices in a more efficient manner. One of concrete's biggest drawbacks is that it creates dark buildings that do not effectively conduct light. Experts are working to change this.
Okay, this is a piece of light transmitting concrete. It seems like an odd concept, but what they've done here is to take standard concrete and add glass fibers. Okay, so what you're seeing here is the blue LED passing through the glass fibers that are embedded in the concrete.
Imagine concrete allowing light to pass right through it, or for someone to cast a shadow through a concrete block.
The same thing can happen with normal daylight as well. So the idea is that you can build a structure with this concrete and allow daylight to actually come through the structural element of the concrete.
Light transmitting concrete, or litricon, is a unique form of concrete that uses glass fibers to conduct light. It allows for massive structures to permit light to shine through. This technology has the potential to redefine what concrete looks like. Once considered cold and impersonal, these new forms of concrete are transforming the material. What started off as the most basic of building materials is now on the cutting edge of building and design. The future for concrete is virtually limitless.